Welcome back. The objective of this video is to study orders of magnitude and logarithmic models. And we'll study order of magnitude to compare any like quantities. So in step 1 here, we're going to use our calculator to compute log 3 times 10, log 3 times 10 to the second. We've got log 3 times 10 to the third here, and log 3 times 10 to the 10th. Of course, these are all log base 10. So we just put each of these values in our calculator and we come up with 1.477, 2.477. Now we don't have log of 3 times 10 to the third, but that would be the 3.477. And then finally log 3 times 10 to the 10th is 10.477. What is the pattern in the integer parts of these numbers? Well, we can see here that the pattern in the decimal part is the same. So the pattern in the integers we also see is just 1, 2, 3, all the way to 10. And then the pattern in their decimal parts are the 0.477, and that goes for each part. So in question 4, how many orders of magnitude greater is 3 times 10 to the 10th than 3 times 10 to the first power? And the answer to that is it's 9 times greater, because 10 to the 10th, or the exponent on 10 minus the exponent on with 10 to the first, is 9 times greater. So 10 minus 1 is 9, and we get 9 times greater. Here's an example involving the Richter scale. The intensity levels I of 2 earthquakes measured on a seismograph can be compared by the formula log base 10 of I sub 1 over I sub 2 equals m sub 1 minus m sub 2, where m is the magnitude given by the Richter scale. In example 8 asks how many times more severe was the 2001 earthquake in India with a magnitude of 7.9 than the 1999 earthquake in Athens, Greece with a magnitude of 5.9. So we can say that magnitude 1 minus magnitude 2, or 7.9 minus 5.9, equals log base 10 of the intensity of magnitude 1 divided by the intensity of magnitude 2. Well, 7.9 minus 5.9 is 2, equals log base 10 of I sub 1 over I sub 2. Using what we know about exponential functions, what we're saying here as the exponent on 10 would be 2. If we converted this to exponential form, we would get 10 to the second equals I sub 1 over I sub 2. So we can say then that 10 to the second is 100, and that the magnitude of the India earthquake was 100 times greater than the magnitude of the Athens, Greece earthquake. In example 9, we're going to use a pH scale model where pH equals the opposite of the log of H plus. You guys in science probably know what that means. Is a scale that measures how acidic or basic a substance ranks. The scale ranges from 0 to 14, where 7 represents neutral, and each whole pH value below 7 is 10 times more acidic than the next higher value. So let's take a look at our formula. The 10 times makes sense because we've got log base 10 here. So the vinegar has a pH of 2.4, and a box of baking soda has a pH of 8.4. So for the vinegar, we can say 2.4 equals the opposite of log base 10 H plus. Or writing it in exponential notation, we have 10 to the negative 2.4 equals H plus. Putting that into our calculator, 10 to the negative 2.4 gives us 3.98 times 10 to the third. Pardon me, 10 to the negative third. And apparently that's moles per liter is the units on that. So that was just a calculator function there that I did. So let's try the baking soda. We'll do the exact same thing. We get 8.4 equals the opposite of log base 10 h plus. Putting this in exponential notation, we have 10 all raised to the negative 8.4 equals h plus. When we put 10 to the negative 8.4 in our calculator, that's going to be a pretty small number, and it does come out to 3.98 times 10 to the negative ninth equals h plus. And just like in our last problem, we can just compare the exponents, and it appears how many times greater. So I'm answering question B. How many times greater is the hydrogen ion concentration in vinegar than the baking soda? So that's where my H plus is, hydrogen ion concentration. So I can do some quick division. 10 to the negative 2.4 over 10 to the negative 8.4 equals 10 to the sixth. So the vinegar is 6 orders of magnitude greater than the baking soda. And that wraps up this video on comparing intensities, and we'll get some more practice with this when I see you in class.